Okay, welcome to another video. In this video we're going to be looking at simultaneous equations, or you might see this referred to as simultaneous solutions. So you're trying to solve, you've been given two equations and two unknowns, and you're trying to find out what values for those unknowns work for both equations. Now we have three ways that we can do this. One is using substitution. The other is using elimination, and then the third one is by graphing. So with substitution, usually it's where we're seeing that one of the variables is isolated on its own, and we can substitute that into the other one, or it's easily isolatable. In elimination, we're looking where we have in our system of equations, we have one of the variables has a positive and negative version of the other. So we might have something like 3x plus 2y equals 21, and then our other equation might be 5x take 2y equals 6. And so we've got the plus 2y and the take 2y. So I'm going to go through an example of each of those types. I'm not going to go through the graphing because you tend to be asked to do them algebraically. If you're graphing them, you're just graphing those two functions either by hand or on your calculator and seeing where they cross and reading off that solution. So this example here, we've got 3x plus 2y equals 21, and we've got y equals x minus 2. So this forms the type of substitution because we have our y on its own and it equaling to something on the other side. So what we're going to do is where we see that y, we're going to write x minus 2. So up here where we've got the y, we're going to put in the x take 2. So we're going to rewrite this equation as 3x plus 2 outside of x take 2, because we've taken that x take 2 and put it in where the y was up there. That's why we call it substitution, this method, because we're substituting the x minus 2 for the y. So then we can, now you can see we've only got one variable. So that's what we're attempting to get, so then we can solve. So we've got 3x plus, when we expand that out, we get 2x take 4 is equal to 21. We can do 3x plus 2x is 5x, take 4 equals 21. Add 4 to both sides. We get 5x is equal to 25. And then we can divide by 5. And we get x is equal to 5. Now the last step, and don't forget to keep going after that, we've solved what x is, but now we need to go back and find out y. It's easiest for us to put it into this one up here where we have y equals x minus 2. We can use the other one, there's nothing wrong with that. It's just easier to substitute into this one because we have our y on its own. So we've got y is equal to x take 2. Now we know that x is 5, so we write 5 take 2 is 3. So then you can write your answers as either x equals 5 and y equals 3, or you could write it as the coordinate 5, 3, because we have x and y here. So you could write it as a coordinate, and when you graphed it, that's where you would see it would cross. Okay, looking at the next example, we've got is 3x plus 2y equals 9, and x take away 2y equals minus 5. So looking at that, I can see that I have the plus 2y and the minus 2y. This is telling me that elimination is a good method for this one. Now with elimination, you also can do ones where you have the same. So if we'd had a plus 2y there, and that's where you'd subtract one from the other. So we've got 3x plus 2 equals 9, x take 2y equals minus 5. So our first step is to add each of those, and we've lined them up underneath each other, so that works really well. So 3x plus x is 4x, 2y take 2y, or 2y plus negative 2y, is going to give us 0, and 9 take 5 is 4. So now we have eliminated one of the variables, and that's why it's called the elimination method. So now we can write that x is equal to 1, because we can divide by 4 there. And so we get x is equal to 1. Then we need to substitute that back into one of the equations, it doesn't matter which one, to work out what the y is. I'm going to choose to go this one just because we've got just only the one x there. So I've got x take 2y equals negative 5. So I'm going to put that x equals 1 in. 1 take 2y equals negative 5. Then I'm going to take 1 from both sides. So I get minus 2y is equal to minus 6. And then I'm going to divide by negative 2. and so I get y is equal to 3. So I've got now x is equal to 1 and y is equal to 3. As a last step, I could go back to the original and check that that worked. So if I had x equals 1, I would get 3 there, 3 times 1, 2 times 3 is 6, 3 plus 6 is 9, so I know that it works. So you can go back and check it in one of the equations as well when you have your solution. Now the lucky last one I'm going to look at is show you how the one could be either substitution or elimination depending how you wanted to approach it. So this one can fit into 2 scenarios. Well, actually it could fit in into a couple more, but I'm going to stick with the 2 simplest ones. So if we wanted to make it a substitution one, we need to rearrange one of them to get a variable on its own. Now this one here is probably the easiest, so I can take the y to the other side and I get 2 plus y. Then where I see the x up here, I can put in 2 plus y. So instead of writing x plus 3y equals 6, I can write 2 plus y plus 3y equals 6. And then I can write that 2 plus 4y equals 6. I can take 2 from both sides, and I get 4y equals 4, therefore y equals 1. And then sub that back into here, x equals 2 plus y, so that will be 2 plus 1, x is equal to 3. Now, the alternate method is to use the elimination method for it. So what we could do is draw our line underneath here and do a subtraction. So we can go x take away x is 0. We've now eliminated the x's. 3y take negative y would give us 4y. And 6 take away 2 is equal to 4. And see how we get to that same part that we got there, but we got a lot quicker. So then we would be able to write y equals 1. Then we could sub into either of those to solve for our x. So you can do a variety of approaches to solve the same set of simultaneous equations, depending how you want to approach it. Another option here is you could have multiplied by 3 and then focused on the y part of it. Hopefully that's helpful with your solving simultaneous equations.